Hey, what's up? It's your old pal, Mr. Cook. We're getting through this review, and I guess let's see. Got through the first five. Now we're going to do six and seven and eight. These are all about linearization, so finding the tangent line approximation for different functions. So it says for number six and number seven, find the linearization um, of the function, find the tangent line of the given easy to compute x value. At the given easy to compute x value. Use the tangent line then to linearize or linearization to approximate the value, the second value. And then is this approximation an over or underestimate of the actual function value? So let's do number six. So number six, when you have to do like a linearization or a tangent line approximation, always start by writing out point slope form. That's the easiest way to make a linear equation. And you'll be given like a value to linearize around, so x equals 0. You just need to find the other part of the coordinate. So if I plug in 0 to my function, right, I get e to the 0 times cosine of 0. Cosine of 0 is 1. E to the 0 is 1. 1 times 1 is just 1. So 0, 1 is the coordinate that we're building our linear approximation around. So this gives us our x value and our y value in the point slope form, the point in the point slope form. So the only thing we need to find is the slope. So we need to find the slope of the tangent line, also known as the derivative. So for that, we're going to go over to our function and find its derivative. So f prime of x. So this is two functions multiplying together, so we're going to use product rule. We get e to the x times cosine of x. That's for the derivative being e to the x. And now for the derivative of cosine, it's going to be negative sign, so minus e to the x sine of x. All right, so now we've got to find this value m, which is the slope of the tangent line at the point when x is equal to 0. So we're looking for f prime of 0, basically. So we plug in 0, e to the 0 times cosine of 0, minus e to the 0 times the sine of 0. Well, the sine of 0 is just 0, so this whole thing goes away. Cosine of 0, again, is 1. E to the 0 is also 1. 1 times 1 is 1. So that means that our slope m is equal to 1. So we just go back over to our tangent line approximation and replace m with 1. And this is our new tangent line approximation. So for part A, find the tangent line approximation or the linearization model. That's this guy right here. All right, and then for part B, it says use this to approximate the second value. So the second value that they're talking about is f of 0.3. So what we do for that is we take this value, 0.3, and we plug it in for the x value over here, and then solve for y. So here's how it's going to look. So for part B, y minus 1 is equal to 1 times parentheses our x value, which is 0.3 minus 0. Okay, so then let's see, we get y minus 1 is equal to 0.3. And if we add 1 to both sides, y is equal to 1.3. So this is going to be an approximation of f of 0.3. So we just write it out that way. F of 0.3 is approximately equal to 1.3. And that's our answer for part B. And then the last question, it says, is this approximation an over or under estimate of the actual function value? Well, okay, there's actually like two ways to do this. The first way is the way that we kind of show you in class, the standard calculus way, which is take the second derivative. So, here's the first derivative, right? So the second derivative, I would just use product rule twice. So f double prime of x is equal to the derivative of e to the x cosine of x is going to be e to the x cosine of x, and then minus e to the x sine of x, just like what we had before. And then plus, and then we got to do the derivative of, this thing. So actually I should put a minus there, I guess. Minus, and then do product rule one more time with this stuff. So I get minus e to the x sine of x. And then the derivative of sine of x is cosine of x. So that's going to be a minus e to the x cosine of x as well. Okay, and then now plug in, your target value, which is 0. So plugging in 0 here gives me e to the 0 cosine of 0 minus e to the 0 sine of 0, and then minus e to the 0 sine of 0 minus e to the 0 cosine of 0. Notice that, these will just be zeros here, and then these are opposites of each other, so they're going to cancel out. So all we're left with is 0 at the end. So we didn't really talk about like what happens when there is no concavity. We talked about if it's like concave up, it's an underestimate; concave down, overestimate. So what happens when it's zero? For that, all you really need to do is just uh, realize that if it's not overestimate, it's not underestimate. What could happen there, right? It could be either essentially. Like if it's an inflection point, like if I have a cubic is typically a nice inflection point. If like I have, centered around zero, then depending on like where my approximation is, if it's like greater than the value, it could be like, an over approximation. Like this would be an over approximation of that value. If it's to the left of it, then it could be like an under approximation. So it depends on the concavity to the left and the right in that case. So the easiest way to do this, believe it or not, to check if it's an overestimate or underestimate, is to like plug the actual number in. So let's find out what f of 0.3 actually is. Just use your calculator. So I'm gonna grab my calculator real quick. Give me a second. Okay, when I plug 0.3 into the function, this function right over here, I can find the actual value, or really really close to it, right? Because it's gonna be rounded to a couple decimal places and stuff like that. But this is like the actual value that you get from the calculator, not from the linear approximation. So if I take e to the power of 0.3 and then times cosine of 0.3, I get 1.2895. So this is like the actual value, and then the predicted value or estimate for f of 0.3 was about 1.3. So is this, is my prediction an over approximation or under approximation? Looks like it's a higher number, so that means it's going to be an over approximation. So, or overestimate, I guess is what they were saying. So if it's like an inflection point, it just kind of depends on if it's concave up or concave down, to the left or to the right. But one easy way that you can always do it is by like actually really plugging it into the function and comparing it to the approximated value that we have. All right, so I'll show you that again in the next problem. I'm just going to repeat the same steps with number 7. All right, so number 7 is a similar example. Since we are doing the same thing, we start off the same way. If we want to find the linear approximation or the tangent line approximation, we start off first by writing up point slope form. So y minus y1 equals m times parentheses x minus x1. And now for number 7, we're using our value pi for x. So that gives us the first coordinate pi in there. And then we use the function to find the y value. So f of pi is equal to the sine of x, which is pi in this case. Sine of pi is 0. And then sine of 0 is also going to be 0. So we get 0 for our y value. Oh, excuse me. Okay, so there's our coordinate that gives us the x1 and y1 value that we're going to plug in. So 0 goes in for y, pi goes in for x. All right, so now we just need to find the slope of the tangent line. And remember, the slope of the tangent line means the derivative. So we got to find the derivative of f. So f prime of x is equal to, this is a chain rule problem. The derivative of the outermost function, sine, is cosine. So we have cosine of sine of x. Then we multiply that by the derivative of the inside. The inside function is sine. The derivative of sine is cosine. So cosine of x follows it up. Gosh, excuse me. Okay, so now to find the slope of the tangent line, m, that's going to be equal to the derivative when our x value is plugged in, so pi. So we've got the cosine of the sine of pi, and then times the cosine of pi. All right, well, sine of pi is 0, so I get cosine of 0 times the cosine of pi. And the cosine of 0 is equal to 1. The cosine of pi is equal to -1. And we multiply those together, we get -1. So our slope m is equal to -1. So I'll plug that on in there. And that gives us our tangent line approximation for this. All right, now moving on to part B. Oh, why did I erase the derivative? Darn it. Oh, well. Well, I got my tangent line approximation. And now I'm supposed to approximate when f is equal to 3. So I plug 3 into my x value. Y minus 0 is equal to negative 1 times 3 minus pi. All right, so if I want to get y by itself, let's see. Well, y minus 0 is just y. And then if I distribute the negative in there, then I get pi minus 3, which is about like 0.14 or something or other, right? Let me just leave it like that, pi minus 3. So that means that my approximation for f of 0.3 is about equal to pi minus 3. That's part B. There's my approximation for f of 0.3. All right, part C. Now, again, let's check to see if it's an over approximation or an approximation. You can do the second derivative test. Let's try it out again. Sorry, I erased the derivatives. Let me just rewrite it one more time. Cosine of x, cosine of sine of x, and then times the cosine of x. And then second derivative. So now we've got the product rule and the chain rule. So I've got like this function times this one. Let's take the derivative of the first one, the derivative of cosine of sine of x. That's going to be chain rule. So the derivative of cosine is negative sine. And then derivative of sine is cosine. And then, so that's this one's derivative, and then times cosine. That's the first part of the product rule. Plus, and then we take the derivative of cosine, which is just negative sine. So we get a negative sine of x. And then times that other stuff, cosine of sine of x times cosine of x. Or no, just that, times sine, of sine of x. There we go. Okay, so now I'm going to plug in where this is centered around, so f double prime of 0, and let's see what we end up with. So we get negative sine of the sine of 0 times the cosine of 0 times the cosine of 0 again, minus the sine of 0 times the cosine of the sine of 0. All right, so let's see here. Sine of 0 is 0, and then the sine of 0 will be 0 still. So 0 times cosine of 1 times, or cosine of 0 times cosine of 0 is still 0. Minus sine of 0 times anything is going to be 0. So that means we get 0 again. So again, not concave up, not concave down. So now we just do the other one, just compare the values. So we have the estimated value. Now let's find the actual value. So if I take pi and plug it in, I get 3 and plug it in, sine of 3. If I use my calculator for that, I get for the actual value. Let me use my calculator one more time. And it's probably in radian mode because we have pi, so make sure you're in radian mode first. And I am, okay. So then let's do sine of 3. I get 0.140652. And let's see what pi minus 3 is. This is about, let's see here, pi minus 3, 0.141592, and so on. So this number, our actual value, is less than the estimated value, so that means we had another overestimate. All right, so there you go. There's number 7. Now let's take a look at number 8. So number 8, write the tangent line approximation at that point for x squared plus all that stuff. So that's all just some like implicit differentiation, and you don't have to really worry about that too much. So it's we practice some implicit differentiation with related rates. So it's just the same rules. All right, so for our tangent line approximation, y minus y1 equals m times parentheses x minus x1. We have the coordinate xy that we can plug in. So y minus 1, and then m times parentheses x minus my x value, so plus pi over 4. Now I just got to find the slope of the tangent line. So that's when I do the derivative here. Okay, so if I do the derivative of x squared is going to be 2x dx plus, and then I have x, and then I also have a y there, so I'm going to get a y prime when I do the derivative with that one. This is also product rule, so the derivative of like the first function, x is just 1 dx times arctan of y. and then plus, now I take the derivative, well, I keep the x in there, and then multiply by the derivative of arctangent, which is going to be 1 over 1 plus y squared, and then y prime. And then that's going to be equal to the derivative of y minus 1, which is just y prime. So I want to get all the y primes on one side, so I keep the other stuff on one side, 2x plus arctan of y. And then I subtract the other stuff over, so I've got y prime minus x over 1 plus y squared y prime. Factor out the y primes, so that gets me to 1 minus that. And then, to keep y prime by itself, just divide both sides. So y prime is equal to 2x plus the arctangent of y over 1 minus x over 1 plus y squared. And then if I plug in my x value and my y value in the coordinate, so y gets a 1 in it. Let's see what we get. So my m value is equal to this derivative if I plug in the x and the y value. And you know what? If we just need the slope, I'm just going to plug the numbers in and just be done with it. I don't even care about finding the actual number. So I'm just going to take this whole equation and plug in the x and the y values from here. And that's going to be my slope. So 2 times x, so that's 2 times negative pi over 4, then plus the arctangent of the y value, which is 1 over 1 minus the x value, which is negative pi over 4, over 1 plus y squared, which is 1 squared. And I'll just leave it like that. I don't really care what the number is, but this is my tangent line approximation. Don't simplify, just leave it like that. You get full credit. Okay, that's 6, 7, and 8. I think I'll leave it at that. So then we'll, looks like start up with the related rates problems after that. I'll probably do a video for each of those. All right, so that's it for this one. Thanks for watching. I'm Mr. Cook. If you need some help, come and find me. Otherwise, track down your calc teacher, get some help from them. I hope you found this video helpful, and I'll see you in the next one. Bye-bye.